So take a look at number 18. You've got a 3 kilogram steel ball, strikes a massive wall at 10 meters per second, angle of 60 degrees. It bounces off the wall with the same speed and angle. If the ball's in contact with the wall for 0.2 seconds, what's the average force? So how do we solve this one? Well, to get going on this one, we know that impulse is equal to the change in momentum. And in this case, the ball is definitely undergoing a change in momentum. I'm going to write it out just a little bit different. In this case, change in momentum, the final momentum minus the initial momentum. Why am I writing out this way? Well, the ball is initially moving this direction, eventually it ends up going this way. Here's where it gets a little bit more interesting. We can actually calculate the momentum. The ball is moving at 10 meters per second, its mass is 3 kilograms, and so its momentum is simply going to be 30. That's its initial momentum before it hits the wall. And then its final momentum is also going to be 30 because it's still going the same speed afterwards. And this time, these are not velocity vectors. I'm actually doing momentum vectors. The question is then, how do we use this? Well, we got to figure out the difference between these two vectors. Well, the problem is we're actually dealing with vector quantities. So before I can do anything with these vectors that are at angles, I'm going to break them into their components. So for this one down here into its horizontal vertical components, this angle down here is going to be 30 degrees, just so you know, you can sort of visualize this right triangle. If we do that then, this side over here is going to be 15. Please forgive me for leaving out units. I'm going to call it momentum in the y direction because it's vertical. And this one down here, momentum in the horizontal, 26. 30 times the cosine of 30. Likewise, we can do the same thing with the final momentum. Up on top, that's going to be 15 in the vertical, 26 in the horizontal. Now notice one thing before we move on here. Both of these vertical ones are pointing in the same direction, both upward, and they're both 15. So the momentum doesn't change at all in the vertical. It just changes in the horizontal. 26 towards the wall from beforehand, and then 26 away from the wall afterwards. So plugging this in, since the vertical doesn't change, we're just looking at the change in the horizontal. So the final, negative 26, because it's moving towards the left. Initial momentum towards the right, 26. Negative 26 minus 26, of course, is going to be 56. But I'm going to go ahead and plug in the time. We know that it's in contact with the wall for 0.2 seconds, so I can plug that in for time over here. And we can actually solve the force, which in this case is going to be about 260 newtons.